Hello everyone. So in this series of recordings I will talk about the rigid body. So this chapter 16, it's about the planar kinematics of a rigid body. The objectives will be that we will talk about firstly the difference between the rigid body and the particle, and then we are trying to understand what is a planar motion, what do we mean by a planar motion, and then we will talk about the components of mechanisms and the relation between them. So this will be the what's the relation between the velocity of each component, and then what's the relation between the acceleration of each component. This will be the main objectives for today. So we will not derive the formulas because we don't have that time to derive the formulas, but what I will do is that I will show the final form of the formula. So what are the applications? The main application of this chapter is the design of mechanisms. If you have a mechanism, it may be a set of gear, it may be the camshaft or whatever, yes, the mechanism. Then we analyze the mechanism, the kinematics of mechanism using the planar kinematics of a rigid body. So one famous example can be the reciprocating action here, like the rectilinear motion, and then we have the general planar motion. General planar motion means that it is a combination of rotation with the translation. And then we have the curvilinear translation, we have the rotation about a fixed axis. So our aim is that, for example, we are trying to understand, so it may be it may ask, say that this is A and this is B, and then we have C, and then we have D. So it may be, the question may be, what is the omega, the angular velocity of the link CB. It may be what is the speed of the point D. So this is the easiest one. Speed of D. The point D is the piston. Or we may have a mechanism like the internal combustion engine, and then the question may be, what is the speed of the point G here in the combustion engine. Or it may be another application that we have a hydraulic window, that the question may ask you what is the angular acceleration and the velocity of the window. So what's the speed of the window when you open it and when you close it. Another application may be that we have a motor that runs a wheel, and then question can be that what is the velocity and acceleration of any point on the wheel. Like, for example, we have point P here. What is the velocity of this point P? Or what is the acceleration of this point P? This may be another application of this chapter. Or it may be about the meshing of two gears. We have the larger gear and we have smaller gear, and then we are trying to understand the angular velocity of gear B, so the bigger gear. Again, we will use today's topic to understand this question. So, or you may have a planetary gear set, and then for this planetary gear set it may ask what is the angular velocity of the gear R. For all of these cases, so you can see the question that's posted here, or it may be that this one, or you may have this question here, and these are the we have the hydraulic pistons here. Okay, again here, what is the velocity of point G? So as you can see, for each one you have the question that is shown here. Or we may have another gear set that asks about the pinion gear. So this will be the Rakan-Pinion. Okay, what is the velocity, angular velocity of the pinion gear, and then what's the velocity of the speed of the point A? Or it may have a slot, something like this one, and then the question may be what is the angular acceleration of the AB link. So I did AB. Okay, so as you can see, the main question in all of these cases is that we have a mechanism and then we are trying to understand the relation between each part of the mechanism. So let me summarize it here. So actually it is geometric. Okay, and then thus, so we can find velocity. Let me start from the simplest one, the distance or displacement. It may be the velocity or it may be the acceleration. Okay, and then I will talk about the topic of each part of this chapter in the next recordings.